Hello, guys. All right, if you would please grab out your packet for Probability 2 Organizing Outcomes and Student Guide. All right, we're going to go through this packet together and we're going to learn on something called an organized list and a tree diagram. So there are two ways to find sample space for a series of events, is to make an organized list or to create a tree diagram. My favorite. All right, so we're going to study and we're going to look at both possible ways. All right, so how many ways? It looks like I have 2 jars and I'm going to be pulling a single block out of 2 jars. So I'm going to pull 1 block out of jar 1 and 1 block out of jar 2. Okay, so make an organized list of all the possible ways. All right, so this is our BY. Okay, I'm going to do this. BYR, YRB. So that way you can at least see. Okay, so if I pull 1 blue block from jar 1, what block can I pull from jar 2? Well, I can pull a Y, I could pull a blue and an R, and I can pull a blue and a blue. Okay, well, can I pull 1 blue and then 1 more color that I haven't pulled yet? Nope. All right, so I'm done with my blue block. Let's say I now pull out a yellow block. What all colors can I pull with a yellow in my second jar? I can pull a yellow and a yellow red, and a yellow blue. Are there any other combinations I can come up with? Nope. All right, now I'm going to pull my red block. I can pull a red, yellow, red, and red, blue. Can I come up with any other combinations to create my organized list of all the possible ways to pull 2 blocks, 1 from each jar? No. All right. So I'm going to answer the few questions with my organized list. What is the probability of pulling 2 red blocks? Well, how many times did I pull 2 red blocks? Well, it looks like I pulled 2 red blocks 1 time. Okay, once. Out of how many options, how many possible outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I was able to pull 1 out of 9. I have a 1 out of 9 chance to get a red. Okay, 1 out of 9 chance to get a red. All right, let's look at the next probability. What is the probability that I pull a red block and a blue block? So I need to pull a red and a blue. Now, it can be red, blue, or I can pull a blue, red. I need to pull at least a red and a blue. Well, this is blue, Y, blue, red. Well, there's 1. Blue, blue, yellow, 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 red, yellow, blue, red, yellow, not there, red, red, nope, red, blue. Well, how many times can you pull out a red and a blue? Well, that's 2 out of our total of 9 possibilities. 2 out of 9 possibilities. All right. Okay, so this is how we can use an organized list to help us answer these questions. Let's take a look at a tree diagram. So I'm still going to use the same concept. Okay, I want to know, or let's make a tree diagram for all the possible outcomes. Okay, so I'm going to create a star and I'm going to create branches. So I'm going to have some branches coming off of my star and I'm going to make 3 branches. Does anyone know why I have 3 branches to start off with? Because I have 3 colors in jar 1. So each set of branches are my draws, if you would say. So from jar 1, I can draw a blue, a yellow, or a red block. Okay. Now that's for my first draw. Okay. To signify a second draw, I'm going to create another set of branches and I'm going to branch off 3 more times. Because from blue, I can get either yellow, red, or blue. Yellow, red, or blue. When I draw a yellow, I can get yellow, red, or blue. And if I draw a red, I can get the same three combinations, yellow, red, or blue from jar 2. So when looking at a tree diagram, when I'm asked, how many outcomes do I have from my tree diagram? I'm going to look at the very last set of numbers or letters, very last set of branches, and I'm going to count the number of branches. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. To have 9 total outcomes. To have 9 total outcomes. Okay, let's look at the top on the second page. So a student incorrectly drew the following tree diagram to model the previous problem of picking one block from each jar. They chose to do start, blue, white, yellow. Okay, that looks like that's what they did for jar 1. All right, so we can go ahead if we want to label it jar 1. And they started here, yellow, red, blue. Well, that looks like that's from jar 2. So what do you notice? What is wrong with this tree diagram above? Okay, now remember our event was to draw one color from each jar and combine. Okay, basically we were to draw one color from each jar and combine them. So what do you notice was wrong with our tree diagram above? Okay, well, the first thing I noticed was I have 2 separate trees. Okay, these 2 tree diagrams are independent of one another. This one says, okay, I drew a blue in my first jar. That's it. I drew a blue and then I put it back. All right, I'm done. I need to draw one color from each individual jar. So I need to combine the 2 trees together to create one event that's going on. Okay, and then the second thing I noticed was that they did not show all outcomes between jar 1 and jar 2 together. They only show the outcomes for jar 1 separate from jar 2. Okay, let's look at another example. Monica used a coin and the 4 aces from a deck of cards to create a game to play with her sister. What are the 2 events in the game? So what are the 2 things that I'm using inside of my game? Well, the first thing is a coin. Okay. And the second event are my 4 aces. So what are the outcomes when flipping a coin? So I have 2 outcomes. I have heads or tails. What are the possible outcomes when drawing a card? So I have 4 aces. All right. Inside of a deck of cards, you have hearts, diamonds, spades, and clubs. So you're going to have 1 ace of hearts, 1 ace of diamonds, 1 ace of spades, and 1 ace of clubs. So I am asked to draw a tree diagram in the space below to show all the possible outcomes when you flip the coin. So that's my first event, and then draw a card. And that's my second event. Okay, so I'm going to start and I'm going to draw a star. And what is the first event that I need? So I'm going to label this event 1. And the first event is flipping a coin. So I'm going to have 2 branches coming off the beginning, and flipping a coin, I could have heads or I can have tails. Okay. Event 2 is drawing a card. Now, once I flip my head, now I'm going to pick, once I flip a coin, I land on heads. Now I'm going to pick a card. So how many options do I have in picking cards? I have 4. So I'm going to draw 4 branches coming off of heads. And I'm going to label them hearts, diamonds, spades, and clubs. And I need to do the same thing because if I flip tails, I can draw hearts of diamonds, or ace of hearts, ace of diamonds, ace of spades, and ace of clubs. Okay. So how many outcomes can we have in all? I can have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 total outcomes. I have 8 total outcomes. All right, let's try it again. What are all the possible outcomes when this spinner is spun twice? So let's think about the outcomes. All right, so it's kind of hard to see. Red or green, blue, and red. These are my colors. Okay, so I'm going to spin my spinner 2 separate times. Okay, so let's say I spin and I get green the first time. What other colors can I get the second time? Well, I can get green the second time. I can get blue a second time, and I can get red. So green, 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 blue, and green, red. Can I get any other colors with green being the first, any other colors the second time? No. All right, let's start with blue. I can have blue, green, blue, 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 red. Can I have any other combinations for blue first? Nope. All right, let's try with red first. I can have red, green, red, blue, red, red. Can I have any other combinations with red first? Nope. All right. Let's try our tree diagram. So I'm going to start with my little star. And I'm going to label spin 1, spin 2. Now, how many outcomes can I have in spin 1? Well, I can have red, green, and blue. So it looks like I'm going to have 3 options: red, green, and blue. Okay, so I get red the first time. How many options can I get on the second time? Well, I can get 3 on the second time. And I can get red, green, and blue. The same thing for green. I can have 3 options: red, green, and blue. And the same combinations are possible for blue: red, green, and blue. So let's see, did I come up with the same number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9. For this one, 9 total. How many outcomes did I come here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9 total. So what is the probability of spinning and landing on blue twice? Be sure to use the correct probability notation. All right, so I want to know the probability of blue twice. So let's see. I have green, 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 blue, green, red, blue, green, blue, blue. Right here, blue, red, red, green, red, blue, red, red. All right, so it looks like I have 1 chance here. Okay, let's see, does it match up here? Now, to read a tree diagram, you're going to read it this. You're going to start with red, red, green, red, red, and then red, blue. Well, remember, I have to have 2 blues, so I'm going to go down to blue, And I can go blue, red. Well, does that work? No. Blue, green. Nope. Blue, blue. That works. It's this combination right here. So out of all of these, how many did we circle? And we circled 1. So I have 1 out of 9 possible chances to get blue twice. Okay. All right. For the classic picnic, each student will order a box lunch by choosing 1 sandwich, 1 side, and 1 drink. So for my sandwiches here, I have turkey, ham, and peanut butter. I can choose carrots and apples for my sides, and I can choose water or fruit punch for my drinks. Okay, so I need to list all of the possible outcomes below. You may abbreviate things like peanut butter using PB, which is what I've done as I read them for short. Assume that you must choose 1 item from each category. You may use a tree diagram or an organized list. Let's go ahead and use a tree diagram so that way we get a little bit more practice with it. All right, so I'm going to move this way. There we go. All right, so I'm going to go all the way down here, and I'm going to start with my star here. Okay, so if you think about this going through the lunch line, you start with your main food, then you get your sides, then you get your drink. So I'm going to start with my sandwiches. Okay, so what are all of the possible branches I can have? How many do I need? I need 3. Okay, so I'm going to start up here, here, and here. So I can get a turkey, ham, or peanut butter. Those are the 3 options I've got to choose from. Okay, once you have it, so say we start with a turkey sandwich, then I need to go to my sides. Okay, well, once I have turkey, I can choose either carrots or apples. Okay, well, let's say I choose turkey and then carrots. Now I've got to choose a drink. I need to choose either water or fruit punch. Well, wait, what if I decide to go turkey and then apple slices? What are my drink choices then? Well, there's still going to be water or fruit punch. So with this example here, I want you to go in and I want you to pause the video and take a moment to fill in the rest for if you chose a ham sandwich, what were your sides be and your drinks? And if you chose peanut butter, what were your sides be and your drinks? And then come back and check your answers with me. All right, you can choose either carrots or apples. Carrots or apples. You can get water or fruit punch. Water or fruit punch. Water, fruit punch. Water or fruit punch. Okay. And now you should have a very pretty tree diagram. And we're going to use our tree diagram to help us answer the questions on the next page. All right. Let me scooch it up here. So, how many total combinations are in your sample space? So how many total combinations did we come up with? So I'm not going to choose 3 because do I only have 3 combinations? No. Do I only have 6 combinations? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total combinations in my sample space because I can do turkey, carrot, water, turkey, apple, fruit, or turkey, carrot, fruit punch, turkey, apple, water, turkey, apple, fruit, ham, carrot, water, ham, carrot, fruit punch, so on and so forth. Okay, now I need to see how many lunch combos include carrots. All right, so this is where we need to go in and take a look. Let me see if I can find a highlighter. There we go. How many of these include carrots? Yeah, include combos with carrots. All right, so I can have turkey, carrot, and choose water. I can have turkey, carrot, and fruit punch. Okay, so there's two. I can't do turkey, apple because I need carrots as my sides. All right, so what if I chose ham? Well, I can do ham, carrot, water, ham, carrot, fruit punch. All right. Or I could have chosen a peanut butter and jelly sandwich with carrots and water, or PB and fruit punch. So how many combinations did we come up with that include carrots with our lunch? We came up with 1, 2, 3, 4, 5, 6 different combinations that included lunch. All right. So it says here, okay, it says Janet forgot to order her lunch, but luckily the cafeteria made extras. There is one of each lunch combo left. All right, so if we had 12 combos in all, and they made an extra of each, how many extra combos do we have? We should have 12 extra combos. Okay. Of those 12, I want to know what is the probability that the teacher gives Janet a combo that includes a turkey sandwich. So I want to know the probability of a turkey sandwich. Okay, there are how many extra combos? There are 12 extra combos. And I want to know how many of those, so how many of these extras, so I have 12 extras, one of each, will include a turkey sandwich. So I'm going to go back and look at my tree diagram. So in turkey, I can choose carrot or sides, and I can choose water and fruit punch for carrot. So I have 1, 2, 3, 4. So from turkey, I have 4 different options, 4 different combos that I can have. Well, can 4 over 12 reduce? Yeah, I can reduce it by 4 to have the probability of a 1 in 3 chance of getting a turkey sandwich combo. To get a 1 in 3 chance of a turkey sandwich combo. All right, and let's take a look at how this student drew their tree. So a student incorrectly drew the following tree diagram to model the previous problem of picking one sandwich, one side, and one drink. So what did the student do wrong? Well, the first thing the student did was they used the categories as their branches. They use the categories as their branches. When we start, we have to start with our first category and the options from the first category. So just like we did here, I started with sandwiches as my first category, okay? So from my branches, I started with the options from the first. So turkey, ham, and peanut butter, okay? And then the second thing is they did not create combos you can get. Just listed what was in the lunch. They just listed what you can get. They didn't give you, oh, you can get a turkey, apple, and a water, or a turkey, apple, and a fruit punch, or a turkey, carrot, water, or a turkey, carrot, fruit punch, so on and so forth. If you guys have any questions, please let